Welcome back to Math 107 College Algebra. In this video, we're going to take a look at how to solve quadratic equations. So the first idea that we're going to use is the zero factor property. That says if AB equals 0, and A equals 0, or B equals 0. So we can use that with an equation like x squared plus 5x equals 24. So I can't use the zero factor property as it is now. I could factor the left-hand side and I get x times x plus 5 equals 24, but I don't know anything when it comes to things multiplying to be 24. Instead, I can subtract 24 from both sides. So I get x squared plus 5x minus 24 equals 0. So that will factor as x plus 8 times x minus 3. And then we can set each of those factors equal to 0. And I end up getting x equals negative 8, or x equals 3. So that's the zero factor property. It works when the quadratic that we're working with factors. But what if it doesn't factor? So we could use, the textbook goes through the whole method of completing the square. That is really useless mathematics. We're not going to end up using it again. I personally would never solve a quadratic equation by completing the square. So we're going to use completing the square for one purpose. We're going to solve a generic quadratic equation. So ax squared plus bx plus c equals 0. So the first thing I need to do is subtract c from both sides. And now, because I don't want to mess with that coefficient on x squared, I'm going to divide by it so that it's in essence just a 1. And now, I'm going to go ahead and complete the square here. On the left-hand side, I'm going to leave it as b over 2a squared. On the right-hand side, I'm going to actually go ahead and square it. And now, I'm going to go ahead and factor the left-hand side. That's going to be x plus b over 2a squared equals, I'm going to go ahead and get a common denominator, so that's going to be 4a squared, so it's going to be minus 4ac over 4a squared plus b squared over 4a squared. And we'll go ahead and put that over a common denominator, and I'm going to write it the other way around. So it's going to be b squared minus 4ac over 4a squared. And now let's take the square root of both sides. So I end up getting x plus b over 2a equals, I need plus or minus here to account for both possible square roots. Numerator I can't do anything with, so it's going to be b squared minus 4ac underneath the square root. The denominator, however, I can take that square root. It's 2a. Now I can subtract the b over 2a from both sides. And finally, just put that over a common denominator. So I get x equals negative b plus or minus the square root of b squared minus 4ac. All of that divided by 2a. Which you probably recognize from previous work as the quadratic formula. So we can use that to solve a quadratic equation such as 3x squared plus 12x minus 6 equals 0. Now if I didn't have it equal to 0, I'd have to make it equal to 0. Since I have it here, all I have to do is plug it in. So it's going to be negative 6 plus or minus the square root of, I'm sorry, I messed that up. It's going to be negative 12 plus or minus the square root of 12 squared minus 4 times 3 times negative 6, all divided by 2 times 3. Then we'll simplify. It's going to be negative 12 plus or minus the square root of 144 plus 72 all over 6. So it ends up being negative 12 plus or minus the square root of 216 divided by 6. There happens to be a factor of 36 inside that radical. It ends up being 6 times the square root of 6 divided by 6. And then I can cancel the factors of 6 and I end up with negative 2 minus the square root of 6. So, one thing that's nice about the quadratic formula is b squared minus 4ac term underneath the square root. That tells us some nice things. If it's positive, we're going to get two real solutions. If it's negative, we get no real solutions. But we'll talk in the next section about expanding our number system so that that has solutions. And if it equals 0, we get one real solution. And I'm going to put here for completeness that it has multiplicity of 2. We will talk about that in Chapter 3. So, that will do it for this video, and I will see you in class on Tuesday, where we will look a little bit further into the concepts behind this.